Okay, so earlier I was talking about the general social environmental issues, and now I would like to specifically focus on the environmental assessment. And when you talk about environmental assessment, there are certain steps that are stages that are needed, and these include uh, uh, the main important part is the screening of the project. And basically, when you are doing the screening, you are basically using what is known as the, let me just, uh, when you do the screening, you are normally using what is known as a checklist to decide whether the EIA, a full environmental impact assessment, is required or not, and to identify the key impacts. And the impacts are identified on the biophysical aspects, on the social aspects, and other um, um, aspects. And the other thing is we also have to make sure that we evaluate all the alternatives, the options. What are the options available for this project? Is this the best option? That has to be done. Then you need to do a preliminary assessment of the environmental impacts. Then based on that, you do what is known as a scoping. This is a very important part of an environmental assessment, and you involve all stakeholders, all interested parties. And scoping is basically trying to identify the most important impacts that needs to be considered, because some projects impact one area more than the other. So this is very important. Then you go to after the scoping exercise, then you have the main environmental impact assessment, which determines the impacts and their significance. And as I mentioned, you have to do a mitigation measure. Where mitigation is not possible, you have to go for a compensation, as I just mentioned. And finally, the whole framework, after the project is completed, you do a review, whether all the mitigation measures were successful or not. Then you do a final audit monitoring after the project completion. So this is in general the environmental assessment. In terms of process, basically, there, as I mentioned, the same thing, I put it in a flow chart. The screening, scoping, the environmental baseline, the key impacts is first done. And based on this, an EIA study is needed or not is decided. Then after that, you do the prediction of impacts. What will happen? What are the impacts that will be happening? What is the significance of these impacts? How serious they are? And then how to mitigate them, how to avoid them. If not possible, how to mitigate them, you have to take care. Then you basically prepare environmental impact statement, which includes the non-technical, not just the technical aspect. And basically you do the environmental impact statement is reviewed. So in all these 4 steps, public consultation is a very important part, especially for the screening part, the prediction part, and the review part. And based on this statement, you make a decision on the project. Basically, this statement is the EIA process, and you make whether you should go ahead with the project or not is made here. And of course, after the decision is made, the monitoring, the auditing has to be done in a regular process. This is just a normal process that the World Bank, the African Development Bank, and most governments, including, in fact, Mozambique, follows. I did a quick review of the environmental regulation in Mozambique. And this is preliminary because actually I, based on the literature I could find, I could do it. And basically I found one, I think there is an investment board of Mozambique, which has a website which it lists the environmental requirements. But I wanted to present this now so that you can have an idea. I mean, most of you must be familiar with this, but I just want to make sure that when you do a new development, hydropower project or a water project or other roads or transmission line, you have to follow these regulation of the government. And correct me if I'm not wrong, the main uh, ministry responsible for the environmental licensing of EIA is the Ministry of Land, Environment and Rural Development, based on that document that I had access to. And I'm told there is a 2015 ministerial decree that guides the environmental regulation. And according to this regulation law, there are 4 categories of projects have been defined. A plus are very complex projects which has irreversible environmental changes, relocation of people, and impact on biodiversity. A is with significant impact on people and sensitive environmental areas. So comparatively, A is less impact than A plus. B do not have significant impact on environmental or people, and C do not have significant impact on environment, people, and sensitive area. So basically B and C, I put it same here. Maybe there is some, maybe I made some mistake in typing this, but you have 4 categories. And I would assume that normally micro, mini hydro will fall under B or C, in fact, even in C. But whereas large hydropower projects will fall on A plus, okay? Because you have to have resettlement, you have to relocate. So you have to have a resettlement action plan, a full EIA has to be done, and other aspects has to be done. So it is important that we follow this regulation. And as Mr. Vaz mentioned earlier, if it is international bank like World Bank or African Development Bank funding, you have to follow their guidelines and national guidelines. But national guidelines normally are as good as the international guideline also. Now, according to this regulation, the A plus category projects have to do an EIA, and you have to do basically, before you do the EIA, you do what is known as the pre-viability, environmental pre-viability and definition of scope study, the scoping study, as I mentioned. And this A plus has to be by an supervision by an independent expert reviewers with proven experience. So this is necessary. A positive, A projects also have EIA and the EPDA, but according to this document, you don't need an independent expert reviewer. For B projects, you have a simplified environmental assessment. So this will be just a checklist with the mitigation plan. And for C project, good environmental management project are basically prepared by the proponent, the project developer itself. So this will, and as I mentioned, mini and micro will either be in B or C. A mini, slightly larger one, maybe in B, but micro obviously will be in C. But A and A plus are large hydro. Okay, now what are the key parts, information that is needed in the what is known as the environmental pre-viability and definition scope of study? Based on this document, basically you have to do a brief biophysical and socioeconomic information of the area has to be provided, and information about the environment of the area of the implementation of the activity has to be provided. And so basically what it means is current land use in the area, what is the description of the activity, descriptive memory of the activity, means what are the steps of the activity, information on the stages of the EIA, and the justification of this activity, legal framework of the activity. This has to be provided during the EPDA study according to the preliminary review. This is based on the legislation in Mozambique. And correct me if I'm wrong, but I just present this so that you have an idea for discussion. Okay, and for the EIA, based on the EPDA, terms of reference for EIA is submitted to the the directorate. The TUR should include description of specialized studies for category A plus and category A, the methodology for evaluation of ecosystem services, including description of viable alternatives and additional information and requirements. The methodology has to be clear on identifying and assessing environmental impacts, especially the impacts of climate change and vulnerability to climate change and biodiversity, including residual and social impacts on the construction, operation, and deactivation phases. So the QR has to be very clear. And the report to be submitted with all the results and the respective management plan. So there's an environmental management plan that has to be prepared to meet the final approval and issuance of the respective environmental license with the approved terms of implementation. Once this is done, then you can implement the project. So this is a very important part of the EIA. And as I mentioned, for mini and micro, I assume that a simplified environmental assessment or good management practice procedure, it falls under B and C is enough. But for large, then you need with substantial resettlement, environmental impact, you have to go for a full IA. Okay, so now this is the environmental part. And now I would just like to talk a little bit about the impact of climate change. And this is a big topic, and especially for mini and micro hydro, the impact of climate change would probably be limited because you don't have big structures, you don't use too much of water, but still, even for small and mini hydro, the availability of water is important. So you have to be careful that the water available in the river that you think is available for you is available and will be able to meet the energy generation. So basically, the International Hydropower Association in 2019 has prepared what is known as the Climate Resilience Guide. Okay, as you know, this is the projected climate change, the change in temperature from like pre-industrial stage to like before 1950s, early 1900. This was the pre-industrial phase. The temperature rise up to 2100. It may rise up to even 2 or 3 degrees Celsius above the pre-industrial stage. This is based on the Intergovernmental Panel for Climate Change, UN or an international body that does the projection of change in climate, in temperature. Okay? And this, the orange and the blue are based on different scenario, okay, greenhouse gas scenarios, and these are referred to as representative carbon pathway, which is like there are 4 scenarios: 2.6, 4.5, 6, and 8.5. Based 2.5 is the lowest greenhouse gas scenario, and 8.5 is the highest. So there's more greenhouse gas in 8.5, which will increase the temperature by almost 3 to 4 degrees. And according to the Paris Agreement in 2015, the Paris Agreement says that the global climate change has to be restricted to 1.5 to 2 degrees Celsius by 2100 AD, compared to the pre-industrial temperature, global temperature. And what International Hydropower Association has seen is the temperature change is certain. By how much, it's very difficult to say, because it depends on the emission scenario development pathway that big countries, every country in the world takes. So it is hugely uncertain, but the rise in temperature will have severe, significant impact on the climate. on the precipitation, evapotranspiration, and other climate parameters, as well as the hydrological processes, no? Because when the precipitation, rainfall pattern changes, when there is very high intensity rainfall, you have more floods. When there is no rainfall for long period, then you have drought. And these hydrological processes, these will influence hydropower generation performance. So climate change will impact hydropower generation significantly. How much is a question. In which aspect is also a matter of study. But we have to make sure that our future hydropower development is resilient. By resilient, what I mean is the objective of developing this hydropower is not disturbed due to climate change. So we have to be careful about that. And International Hydropower Association guideline they have one climate risk assessment methodology that they have developed, and they call this the 4-phase methodology of, in fact, 4. So you basically do you basically first see what is the climate scenario. So you see what are the climate change factors that affect your project. Is climate change, will it make your project infeasible? General. Does climate change affect your project? First, you need to decide. If the project is not affected significantly by climate, the risk of climate change on the project performance is not so high, then basically you just don't need to do any further study on climate risk assessment. But if you think this is climate sensitive, then you should do what is known as the climate initial analysis and a stress test. Then, based on the climate stress test, you basically prepare a climate risk management. One example of climate risk management can be, for example, if due to climate change, your design flood is likely to increase, okay? Maybe your design flood of 1 in 1,000 year, or for small project, 1 in 100 year design flood. If the magnitude increases, then what do you do to make sure your project does not fail with the changed flood? You have to decide, and you have to plan accordingly. And this is what is known as the climate risk management. This is just on the right is a very small, simple example of the change in temperature. Okay, mean annual temperature, what is the thing? And the mean annual precipitation, what is this? So condition. So over here, what it says is from 1948 to 78, this is the red dot is the mean temperature was around 20, and the annual precipitation was little more than 1,000. Okay, but now 79 to 2008, the temperature increase, you see, from red to blue here has increased a little bit here by almost 1 degree in, let's say, in the last in this period, okay, from red to here. In the future, okay, in the future projection, these yellow and the black dots are future projections of climate, precipitation, and temperature for one particular hydropower project. This is from an example from the resilient. You see the variation of future projection is very, you don't know whether now it is from around 20 to 21 degrees Celsius is the thing, but it will increase. It will increase to by 2 degrees or something. And what will be the change in precipitation? The precipitation, some of the models say it will increase from 1,000 to 1,400. Some say it goes from 1,000 to it will decrease by 600. Now, what is the climate risk of the change in precipitation if it increases or if it decreases. If the temperature increases by 1 degree or 2 degree or 3 degree. So this is the future climate. And this future climate is very uncertain. Means because this future climate is projected using what is known as the general circulation models, GCMs. Okay, and these GCM models, there are many models, 50, 60 models done by different research institute, international institutes, using different criteria of and processes. So it's the uncertainty. Nobody knows. Everybody knows that the temperature will rise, but by how much? Like, will it rise by 1 degree or 3 degree? They are not sure, because it depends, as I said, on the greenhouse gas emission. And based on that temperature rise, will the precipitation increase or decrease? It's very uncertain. Half of the models say it will decrease. Half of the model says it will increase. And this is what, like, for example, this is just an example. The dark green or blue color here on the bottom portion is the project is infeasible. If it is above this, project is feasible. So if the precipitation and temperature, if there is no decrease and there is a slight increase, even if the temperature increases, the project will not face a problem. But the temperature increases and the precipitation decreases, then you have a problem with this project. So this is a very simple diagram to show the impact of climate change on a hydropower project. And this bottom line is they take some parameter, maybe energy generation or the internal rate of return. This internal rate of return will change if the precipitation decreases, but we don't know if it decreases by how much. So this is what is known as the climate risk assessment. So you have to design your project to make sure that the project does not fail when the climate change occurs, especially if this type of projection comes true. So this is basically in a very short 2 slides, I'm trying to explain the impact of climate change. This is a very big topic. I have worked a lot in this myself, so I could go on, but I will not do that now. But maybe in the next lectures, if some of you are interested, I can share more information and procedure on this. Okay. Now, based on that, I just would like to have, let's say, 5 or 10 minutes of a short discussion. Okay, please, Carlos, Dr. Carlos, please help me. And you can, if you can speak in Portuguese, if you wish, and then, but I would request Dr. Carlos to just translate the main points to me. If there is a question, I just want to ask you 2 questions. Let's start with the first question. What do you think are the key environmental and social issues of a hydropower project? Okay, I explained all these things, but for hydropower projects to be developed in Mozambique, what is the key environmental issue? What is the key social issue? Is the key environmental issue obstruction of water in the downstream portion? Or is fish migration an environmental issue? Is air pollution an important issue? On social issue, is resettlement the main issue for hydropower project? Or is impact on indigenous population? Maybe your hydropower projects fall in areas of very indigenous tribal population, then we have this problem. So maybe 5 or 10 minutes. Can I have your views? Then after that, I will go to my second part of my presentation on cost and benefit estimation. Okay, just maybe 5 or 10 minutes. Dr. Carlos, can you help me?
Yes, please. You're welcome. Bom, colegas, acho que todos acompanhamos. Temos duas perguntas e as respostas podem ser dadas em inglês ou em português. Se quiserem falar em português, falem devagarinho. Enquanto falam, eu vou escrevendo para o colega Divas.
I would like to address two questions. Say one is the historical and cultural heritage, normally covered by the water when we are talking about dams, and usually this is a big issue that this kind of heritage is normally completely lost after the dam is full. This is one issue that I would like to address. The second one is the microclimates. Normally, when we do have one dam, usually around few kilometers around, the climate, the local climate is changed. In some cases, becomes very humid. Other case becomes very dry. In some case, the the rain stop it, almost stop it, and how to address this. There is another to say comments. I think that climate change is something that we have to take care, because it was quite impossible to make a real foreseens about for the few years. I remember I think 3 years ago, the Zambezi River was almost dried, but Zambezi River is a big river. In some areas of that river, not exactly in Mozambique, but in the other countries where Zambezi rivers goes or went, in this case, the river was almost dry in some areas, and how to deal with this. We saw it also in Brazil, where they got a very big problems on this. Some dams becomes less than 20% of the water, and how to deal with. And also about Brazil, I would like to address another thing is the insurance to the population. I remember that two big accidents they got a few years ago, and I think after I saw the damage caused by the dam, I tried to imagine how is it possible one insurance company or insurance syndicate pay the damage that that dam does to the population and to the people affected. Yes, this is the questions that I would like to address on this regard.
Yeah, thank you very much. I think, Mr. Frade, you raised very important and very difficult questions also. I fully agree with you. This is something very important. Just one small question on this one. Like, for example, in the Zambezi River, you have the Kohora Bassa Dam. So, what is the like downstream of the dam, and you have new dams coming up there in the line also? Uh, did the dam, after the dam was built, after the flow regulation started, did it affect maybe fishery in the dam or other people living just along the river? Did they face any problem?
As I know, it was the micro climate change, especially in one big city that it was around. Uh, my some people but much older than me, they told me, say, in Tet is the city, the capital of that province where the dam is installed. They says that the climate there was totally different of the actual climate. Actually, Tet is a very hot, very hot and humid city, but the whole people says before the dam It was totally
Nabat.
different. The same I can mention about one place where I do have one piece of land, a small piece of land that before the dam of Libombo Dam, before this, the rain comes on normal way, but after they make the dam there, it is a very dry place. Normally, the rain comes very a few years or few days per year, and this is one thing that I feel about the dams. It change or it creates a microclimates around. But I don't know if it's true or not. This is a question that I would like to address to you.
Yeah.
You know much
Thank,
better than me.
yeah. No, thank you. Actually, this microclimate impact is, I think, you need to. It's very difficult to say. It is. There has been. I have seen literature where they have talked about microclimate, especially of large dams, and we need to do more study. But you are right. It does change the micro. It can change the microclimate. Regarding whether the rainfall pattern, uh, I don't know, the microclimate can be one factor, but of course, climate change could be, the global climate change can also may have caused not just in that particular area, but in the other area also. But it needs further studies. I fully agree with you. And also, like you mentioned, insurance. Sometimes hydro projects also has to be designed in a very robust way, because if the dam break, when you do a hydropower design, you do a dam break analysis. If the dam breaks, then what is the damage in the downstream? Because when the huge water flows downstream, it will have a lot of impact. So as you might be aware, the small mini micro hydro designed for 1 in 50, 1 in 25-year return period flood. But big dams like Kohora Bassa would be designed for 1 in 10,000 year return period. So probabilistically, you have a chance of that flood coming one, or it's almost impossible. When you say 1 in 10,000 year or probable maximum flood, it just means that it will be not possible that this type of flood will occur. But we have to be careful. And as you mentioned, insurance is one way. So like you said, the other question is, what are the mitigation measures? Okay. So for example, for historical and cultural heritage, now how to mitigate that? So sometimes, as Mr. Vaz and others also said, that when you design the project, you have to optimize. Is there a way you avoid these historical and cultural heritage? Number one. Number two, if we have to inundate historical cultural heritage, you have to take the people into confidence. You have to convince them. So that's why you say free, informed, uh, informed prior consent. Full, no. So you have to give the full justification why the dam has to be built in that particular historical or cultural heritage. Otherwise, it will create problem. And as you mentioned, climate change now, all major banks like World Bank, if you ask for money from the World Bank, I'm sure African Development Bank does the same, that you have to demonstrate that your project is still feasible, even if there is, like I said, these type of changes in precipitation and temperature. And you have models, hydrological models you have to do economic models to prove that even if the precipitation change from 1000 millimeter to 700 millimeter or increase to 1300 millimeter, you still, the project is still feasible. You have to do that. So, and like you said, insurance is one mitigation measure. Also, like if there is a damage, then you have an insurance policy that will do that. So I think, yeah, it's very important. Anybody else? Please speak in Portuguese, and you can discuss among yourself. And Dr. Carlos will just translate to me just the main points.
Vou falar em português, então. Vou focar, por exemplo, o caso de Cabora Bassa. Né? A Cabora Bassa foi construída há muito tempo e muito provavelmente aconteceram os problemas normais que acontecem com a construção de uma barragem daquele tamanho. Mas se formos a ver os aspectos mais recentes, por exemplo, fala-se muito sobre o problema da barragem de Caribe, que pode vir a ter problemas e pode mesmo, se não for feito alguns trabalhos, pode ter uma ruptura e vir a causar problemas à barragem de Cabora Bassa. Né? Então, isso são coisas que já devem ser discutidas entre as autoridades internacionais. Mas um dos grandes efeitos das barragens é que corta a vida natural de um rio. Então, o que é que se costuma fazer? Costuma-se tentar que a barragem consiga de vez em quando simular fenómenos naturais, como cheias, por exemplo. As cheias, pode parecer mentira, mas são fenómenos naturais que fazem parte da vida de um rio, da vida ecológica de um rio. E são necessários, porque eles varrem alguns sedimentos, são necessários, trazem algumas espécies que estão paradas. Então, há fenómenos naturais que as barragens muitas vezes travam e que depois a gestão da barragem deve preocupar-se em tentar simular o mais próximo possível esses fenómenos naturais. Nós vemos, por exemplo, o efeito de Cabora Bassa nas zonas úmidas mais a jusante, quase no estuário, né? que é uma zona de ramsar. Ao reter esses sedimentos todos dentro da barragem, as erosões jusante começam a aumentar. E isso é um impacto negativo, muitas vezes que só se vê muitos anos mais tarde. Portanto, eu só queria falar um pouco sobre esses aspectos.
I think, Divas, you are reading what I have been writing.
Okay, in chat? Oh, sorry. Okay, let me just. Sorry. I don't know. I will chat. My laptop is.
Oh.
I cannot see the chat somewhere. It should be somewhere. Sorry, can you just briefly explain what is this? Because I cannot see the chat for some reason.
Yeah, do you want to do that, Kamal?
Desculpa?
You want to repeat it in English?
Just briefly, just
okay. You mentioned I could speak in Portuguese, so I spoke in Portuguese, but I can do a summary.
Short.
For example, talking about Cabora Bassa. Cabora Bassa might be at risk if the dam upstream, the Caribe Dam upstream, gets into trouble. You know, for 10 years we've been discussing the troubles that are in the Caribe Dam. It might rupture or break. And if that happens, then there is a disaster downstream. So these are aspects that must be considered. Yeah. On the other side, there was some impacts of Cabora Bassa Dam, like there is impacts every time you build a dam. The World Bank at one time decided it was not their policy to fund more dams, but then they changed their mind. But there was a time that they didn't want to fund dams. But if we talk downstream of the dam of Cabarabassa, one of the big things is that the dams cut the life of a natural river. So, for example, floods that are very important for the ecological life of a river are completely cut. So the management of a dam must try to simulate at times these natural events in such a way that the river life is kept as close to natural regime. We have a case, for example, the humid areas in downstream of near in Sofala. It's a Ramsar site. It's being affected by the reduction of sediments release. You know, it increases the erosion of the areas because the sediments are not there, you know. So these are effects that probably are difficult to mitigate, but if that is associated with cutting of vegetation like mangrove cutting, then it increases the erosion rate. That's what I said.
Oh, no, thank you very much. I think what you said is more than I think we covered today. It is, especially with large dams, especially with the changes in river flows, the regime, as well as you rightly mentioned, when the sediment flow decreases, it's trapped in the reservoir, it can have a lot of downstream impacts. So it's very important. That is one. But I think you very rightly also mentioned that the river can be reservoir can be operated to at least simulate certain flood events also, especially when there is high floods, so that the ecological balance ecosystem, I think that's and now this is the trade-off. When you do that, you lose some energy generation, okay, or something happened. So you have to now do a trade-off. So it's an economic aspect also. But sometimes if the mitigation requirement is there, you have to forego some of the economic benefits also. And I think you are very right. The upstream Kariba Dam, I mean, if there is some disaster upstream, it will also be transferred to Cabarabassa Dam, which will be very unfortunate. So I think you have to have early warning systems. You have to have dam safety, monitoring, everything. And it's a very difficult task, and a lot of difficult in the sense, not technical difficult, but sometimes people don't realize the importance. It's by management, the decision makers don't take it seriously. I fully agree with you. And these are the reasons why large hydropower projects are sometimes mired in controversy. I fully agree with you. Thank you. Thank you so much. Yeah, I think let's now just proceed. Thank you so much. If there is no, or we can discuss later, because I want to cover a little bit of the second part also. So let me just go to the second part. I just want to now come to the costs and benefits. One thing I would like to, if you don't mind, I will just exceed by 10 or 15 minutes more and try to finish. Like I'm now focusing into community, mini and micro hydro projects because isolated hydro projects supply remote communities, and sometimes these rural communities don't have the capacity to fully recover the cost of generation and distribution. And the main challenge is because of the low plant factor, which means that the peak demand is very high, but at other times, off-peak hours, your energy is wasted, you cannot use. So the tariff becomes high. If you want to do the usable energy is only 25 to 50% of what is possible. So in that case, experience from my country and other countries show that partial grants are provided to these community mini hydro projects. So there are special programs in my country. I worked in Afghanistan for a while. In Afghanistan also they have, in Pakistan, other places. So they have programs, government give them grant because they believe that access to energy has a lot of multiplying effects, because $1 spent on energy, the benefit is many dollars, they say. And also the communities are asked to contribute labor and cash, okay? And the remainder, part of it, after grant and subsidy, then part of it is taken as loan from a development bank. This is how micro hydro projects in Nepal are financed, and they are quite successful. Okay. Similarly, examples of other countries like in Pakistan, they give up to 70% grant and 30% community contribution in cash and labor. You know that in Afghanistan, National Solidarity Fund, it gives $200 per household on equipment and construction. This is the grant they give. And Nepal had a rural energy development program. They also give subsidies of $170 to $200 per household to finance these community micro hydro projects. So this was been quite successful. Okay, so this is the community financing part. And the other part which is important is, like I mentioned, we need to know, we will do some exercise in our coming sessions, but I just want to show you that how do you estimate the load, the demand in a particular community. And for micro hydro projects in Nepal, they like the criteria used is they assume that every household will at least use, let's say, 100 to 120 watt. At least they have 3 or 4 lights. Even poor families can light some bulbs. They have 2 or 3 rooms, and they have, nowadays you have very efficient lighting, so 120 watts of thing. And when you fund these micro hydro projects, there has to be a minimum of 10% of productive use, not just for lighting, but for productive use. And they also prefer multi-purpose scheme, that micro hydro project, a small stream used for hydropower as well as for irrigation. So this is the flow chart that they prepared. Okay, this is the, so of course they go to the location and they do a thing. So before, when they decide on the install capacity, how much to install, they look at the what is the present demand and what is the tariff, and they put the tariff and demand, at least for the first 3 years, in 5 slots. They divide 24 hours in 4 or 5 slots, because morning and evening there is more domestic demand. During daytime there is no little domestic demand, because people in rural area just use it for lighting. They don't really use it even for cooking. Okay? So it depends. Now, unless the tariff is very competitive, affordable, they will not use for except for lighting. So also in the future, like they say that when a micro hydro project is built in one community, it takes 2, 3, 4 years for the community to realize the importance of energy use. So they will increase their load. They will start new business, new productive uses, end use load will increase in the future. So, and the tariff can also be for 24 hours same. So normally in the beginning, you say, okay, you just light in the morning, we give you, this will be your tariff. In the evening, you use power, this will be the tariff. Other times, if you don't use, no problem. But in the future, you want the community to increase their end use load. EU means end use. So then based on that, we calculate the annual energy, yearly loads, the end use factor. What percentage of the energy use is end use, productive use, and what will be the yearly income from the project based on the tariff. And based on that, you develop what is known as the load duration curve and a graph which is used for decision making. So this is the way the load and benefit is, because now when there is no electricity supply, you don't know how the use of the energy will be in that area, because people are not used to electricity, you see. So they have other means. But once you have a new source of electricity, automatically the demand will increase. But it will take 2 or 3 years. It will take time for people to start a new business. Now, they will, in the beginning, later on, maybe there will be a small cold storage will be created. Maybe there will be one small, medium, small scale industry, some repair shop with using electric machines will be created. This will change the load pattern. In the beginning, it will be something. In the future, it will be. So this is a very important part of estimating the load and benefits. This will help you at least design the tariff for in the beginning. But in the beginning, you have to have some grants, some subsidies for these projects to take up. Otherwise, the community will not be able to do it. And this is, in the beginning, a small example of a project in Nepal. What they do in a micro hydro project, loads at rural isolated systems are typically dominated by domestic. You see, this domestic load, in the morning, they get up early, they have lights. And probable business, then after 3 years, the business load will increase. You see, now in the beginning, they have a small bakery can use this, some agro processing from 12 to thing, some herbs processing could be there. Then you have different types of load. And this is the installed capacity. Now the problem is during certain peak hours, you don't have enough energy, but in other hours, you have more energy. Okay, now, so this is where you have to be, this is where the load has to be thing. So during the off-peak hours, okay, how to increase the productive use of this energy is important. So the plant factor, the load factor of this demand is very low because, you know, it is the full capacity is not used only part of the day. Other times you don't have enough use of the thing, so of the energy. So this is a very important part of deciding on the benefits. Regarding the costing and financial analysis, typically for micro hydro in Nepal, 15 years of economic lifespan is considered, no? Because I mean, you cannot think of long term. Cost of project, including subsidies, estimated. Cost ceiling. So when you do the funding, you have the maximum cost ceiling, more than, I can give you the number, I don't think. And then you should also see that the net present value, when you do the financial analysis, it should be positive even for a low discount rate of 4%. So basically this is the thing, sources of investment, the payback of loan, discount factor, breakdown of investment cost, annual operating cost is decided. Then based on that, then you have the net present value with and without the probable business load. Because in the beginning, you don't have the business load. You don't have the industry, small industries. But after that, you have it. Then you get the cost per kilowatt. What is the subsidy per household? You get the cash flow, which will then decide on the project costing and financial analysis of a potential micro hydro project. So these are, we will do some of this exercise in the, when you do the feasibility study thing, and we'll try to take some real life situation in Mozambique for that one, okay? And the cost composition, actually I showed this slide to you in my previous lectures also, but it did, like normally the civil works, like in this project has 66% is civil works. In this project by a national IPP, it's only 30%. This is about 3.2, 6.2 megawatt, 6 megawatt, 53. But whereas I give you an example of a mini hydro project, the cost structure is slightly different. Okay, land and support, blue one as 11%, hydromechanical, other things are given here. This one I had already shown. I will not go into the details now. Now, when you create a project cost summary for a micro hydro project, these are the cost breakdowns you have to prepare. Okay, typical cost for mini hydro projects. This was one example of a project study in Nepal. which was electromechanical equipment, cost about 350 to 400 per kilowatt. These are, I think this was a cross flow turbine, something. And steel penstock is about $2,500 per ton. I mean, now this will depend on the local rate in Mozambique. Civil costs, you have to do for the civil cost, you have to prepare the unit cost of labor, cement, sand, gravel, and other materials and labor to be used. So based on that, you prepare a breakdown of cost. And the breakdown of cost should be the owner's camp. You know, you have to have some construction camp. You have some pre-operating cost. You need the cost for construction, power during construction, because you may need a diesel plant to pay for your energy during construction. Contractors camp, main civil construction, headworks, headrest pipe, forebay, tank, penstock powerhouse, hydromechanical installation, penstock pipe, transmission line cost, powerhouse equipment, land and environmental cost. You have to buy some land, then you have to pay for this land. Engineering management is roughly 6% of the basic cost is considered for 900 kilowatt mini hydro project. Physical contingency, because there might be some unknowns, uncertainties. So for civil construction, we put around 10%, electromechanical 5%, others 10%. So based on the detailed feasibility study, this is the amount that we get. And based on that, this is an example of one project of 990 kilowatt mini hydro in Nepal. The civil construction cost was 29%. The hydromechanical SDP was 25%. Environmental cost was 5%. Powerhouse equipment was 16%. And initial infrastructure was including access road, camp facilities was 7%. And other engineering management about 8 to 9%. So this is the general breakdown of the cost. So now if you want to reduce the cost, you have to also look at this. So basically, you have to do a rate analysis. You have to get the unit market rates for the materials, the cement, sand, steel, reinforcements, labor, other things has to be prepared. So this will be part of the feasibility study. We will also consider later. Okay, so basically, I plan to cover this much today. But before I close, I just want to ask you if did anybody calculate the answer to this question? So you want to generate 60 kilowatt of power requirement. You have a head of 100 meter, assuming overall efficiency of 55%. How much flow you need in the river, design discharge you need in the river? Did anybody calculate this?
Caros colegas, será que alguém resolveu este exercício? Caros colegas, será que alguém tentou resolver este exercício?
Sorry, I did not maybe give you. Okay, anyway, since I think it's a, anybody who wants to give it a try, I should have given you some option, but I did not. But I can, in the next slide, I have the answer. So I can show it to you if you want. Okay, I think I'll show you the answer. As you know, power is efficiency gamma QH, okay? And this is in kilowatt, P in watt, if you, sorry, it should be in kilowatt. Then if you want to calculate Q, then you divide, the power was 60 kilowatt was 60, divided by efficiency was 55, and gamma is 9.81, and head was 100. So you need the discharge of design discharge of 0.111 cubic meter per second, which is equivalent to 111 liter per second. Okay. Anyway, this was just a, I wanted to give you some time, but since the time was running short, I gave you the answer. And just to give you, if you have any questions, let us take some questions now. And also, I would like to, before I close, let me just also, I received from our colleague from Funai. Did you? Can you? Sorry. Can you see my? Can you see? Sorry. Let me just. I will share again. Sorry, just a moment. Yeah. Can you see my screen now with the Funai mini hydro project?
Yes, we can see it.
So I got, I had given one assignment to you about mini hydro projects in Mozambique. And I received this from our colleague from Funai. And so he provided me, I thank you for this, the Majao mini hydro project, the discharge, the design head, and other information. Okay. Similarly, you have the Zambezia mini hydro project, and it's not grid connected. You have the catchment area is small, 682.6, and so maybe we will do some. This looks like in a relatively good, it's working condition. Then you have also there is an operational grid connected mini hydro in Manica province, 64. These are small catchments. So I'm and 220.20. So we could do. I will try to see some. I will contact you, and maybe you see there is a. Looks like there is this spillway here from the either the forebay or the thing, and this is the rotunda. This is now going to be connected to the grid, national grid. I think if you connect to the national grid, then you can, when you have extra power, you can give it to the national grid. When you need power, you can do that. So this is like maybe the catchment area 6 kilometers square might be a small, but we can check this. This is not in operation, I understand. And the head is good, 208 meter. It's a Pelton turbine from China. Nice. There's another one, 300 Manica again. This is a cross flow, design discharge, design head. It's a low head thing, and you have a online earthen canal. So these are okay. Thank you very much. I think this is some good information. I will try to see, and I will contact you if I need more information, because I may include this in our feasibility study exercise and get more information and see if we can do some assessment, cost assessment of these projects also. Yeah, thank you so much. Yes, Carlos, I think we are now 11:15. If there are any questions that anybody has, comments? Otherwise, I will close now, and then I will see you, I think, after 1 week, next Friday.
Sorry.
Yes, please.
I would like to correct something there about that information from Funai. When it says grid connection for Shurair, it's not for MOA. MOA. Go to MOA, please.
I think I have some problem hearing. It's breaking. Carlos, do you hear?
Hello.
Yeah, I can hear you. I can hear Mr. Robert as well.
Yes, MOA. You go to MOA information.
Can you hear that, Divas?
It's a little bit breaking. It's not clear. I did not fully understand his.
No, it's not important, but I'd like to correct some information there. You can do this next time.
Yes. Okay. Yes. Yes.
Yeah.
I will
Can do it next time.
I'll contact you. Thank you so much.
Yeah. Okay. Thank you.
Yeah. Dr. Carlos, that is what Mr. Robert mentioned.
Há uma informação para
Era para corrigir qual é a informação?
mas penso que não é muito importante, podemos deixar para as próximas. É só a parte do grid connection que era para pôr.
Qual deles?
MOA.
Divas, can you scroll it up to MOA?
To Moja.
MOA.
Yeah, MOA. Okay.
MOA.
Yes.
Grid connected.
This one.
Yes. On grid, not off grid. I mean. A resposta é off grid.
This is off grid. Okay.
No. Yes, off grid.
This is off grid. Yeah.
Okay. Thank you.
I think the same mistake for. Sorry.
No, I think you have to go up. Sambizay might be a bit up.
Yeah, Sambijay is not good. No.
Yeah.
No, it's good. Shurair, the last one.
Alô, Roberto.
Sim.
Não se ouviu bem o que estava a dizer.
Sim. Pode descer para a próxima. Parece que é uma outra mini hídrica aqui. Tem.
Ok.
Pode descer.
Okay. I think all of them are.
If you continue, scroll down. Yes.
Continue. Yes. Continue. Yeah. There's also off grid.
Okay.
Not non-operation. Yes.
So all 5 are operational now, right?
Yes.
Okay. Thank you so much.
Okay. Yeah. Thank you.
Thank you so much. Yeah, thank you so much. Yes, Dr. Carlos, is there any other question? Otherwise, maybe we can stop now.
Well, I don't think so. Maybe we can stop now.
Okay. Yeah. Thank you very much for your attention. I hope you enjoyed my session. But if there are any questions, please send me email, and you can send through Dr. Carlos, or I think my email address you might also have given at the end. So I'll be happy to answer and discuss further. And after 1 week on Friday, I have my next lecture. I will see you after 1 week. Thank you so much.